Alright, in this video we're going to talk about polynomials and then how to evaluate polynomials. So there's a bit of terminology in this discussion, so here we go. Alright, so here's a note. A polynomial is an algebraic expression that is the sum of one or more monomials. In other words, we're just adding and subtracting a bunch of monomials. Each of the monomials in a polynomial is called a term. So here's an example of a polynomial. 7x to the fifth plus 4x cubed minus x squared plus 3x minus 2. You cannot combine these up anymore because they're not like terms, and so it just stays written as such, and it's called a polynomial. Right? Each one of these individual terms are monomials, and so this particular polynomial has 1, 2, 3, 4, has 5 terms associated with it. Okay, 5 terms make up this polynomial. Now, there are some special polynomials that have certain names. First one's being a monomial, which we've already experienced before. Say something like 5y. So 5y is a monomial, just one term. Whereas a binomial, you might see something like 2x plus 3. So a binomial, it has 2 terms in it, right? It's a polynomial that has 2 terms in it. And then a trinomial, brilliantly enough, is a polynomial that has 3 terms in it. And so we'd have something, say, like 4x squared plus 7x minus 2 would be an example of a trinomial. Right? So we will refer to these names as well for these special polynomials. A monomial, binomial, and a trinomial, and they're all fall under the umbrella of polynomials. Right, so here's a note. There's a certain way we want to write our polynomials. The terms of a polynomial in one variable are usually arranged so that the degrees of the terms decrease from left to right. In other words, the terms are written with their degrees going in descending order. So as we go left to right, the degrees on the monomials get smaller. They go in descending order. Here's an example. 3x squared, the degree for this monomial is 2. Minus 5x, the degree of this monomial is 1. Plus 4, and the degree of this monomial is 0. So the degrees, 2, 1, 0, they go in descending order. That's the preferred way that we write polynomials. Right? The degrees go in descending order. All right, a few more new words. 1. The leading term of a polynomial is the term with the highest degree. The leading coefficient of a polynomial is the coefficient of the leading term. Right? So you find the leading term, that's when we write it in its standard form where the degrees go in descending order, it's going to be the first term there on the left, and that would be called the leading term. Its coefficient will be called the leading coefficient of the polynomial, and the degree of that term is called the degree of the polynomial. Right? The degree of a polynomial is the degree of the leading term. So for example, negative 7x to the fifth plus x to the fourth minus 3x squared plus 2x minus 11. All right, so here's a polynomial. We've written it in standard form where the degrees go in descending order. This first term, negative 7x to the fifth here, right? Negative 7x to the fifth here is called the leading term. Right? Remember, this is after you rewrite it in so that the degrees go in descending order. So this is the leading term. The negative 7 is called the leading coefficient, and 5 is called the degree of the polynomial. All right, so that's the idea on those new words: leading term, leading coefficient, and the degree of a polynomial. All right, so now let's talk about evaluating polynomials. All right, we want to evaluate the polynomial 3x squared minus 4x plus 1 when, all right, we'll have some examples in just a second. The general idea for evaluating polynomials is you're trying to find the value of the polynomial when the variable is something else, usually a number, but it doesn't always have to be a number. All right, could be another expression or something. Right, but you're substituting values, expressions in for the variable x in this particular case, because that's our variable, and seeing what the what happens with the polynomial. Right, so now most of the trouble comes from following the order of operations after we make this substitution. So that's what we're going to need to be very careful about. All right, so let's do the first one. Evaluate the polynomial 3x squared minus 4x plus 1 when x is equal to -2. All right, so we're literally going to substitute -2 in for x into our polynomial here. Now I'm going to advise you to put the -2 in parentheses. Right, so this is 3x squared. We're replacing the x with the -2. Then we have minus 4 times -2 and then plus 1. Get that -2 in there for the x's and then just follow the order of operations to do the arithmetic on this. Right, so this would be 3 times 4. -4 times -2 is going to give you a positive 8 plus 1, so we get 12 plus 8 plus 1, which goes to 21. Right? So the value of this expression here, when x is -2, well, the value of it is 21. Right? Let's try another one. Same expression, but this time when x is 3. So now we're going to plug 3 in wherever we see an x. All right? So 3 times 3 squared minus 4 times 3 plus 1. All right, so 3 squared is 9. Minus 4 times 3 would be minus 12 plus 1. 3 times 9 is 27. 27 minus 12 plus 1. So 27 minus 12 is 15. 15 plus 1 is 16. So the value of this same expression is 16 when x is 3. All right, so can I get the idea? Okay, so now I'm going to change it up a bit. All right, evaluate the polynomial when x is equal to m. I know, it's just another expression. So we're going to take the m and substitute it in for all of the x's, and it would look like 3 times m squared minus 4 times m plus 1. The process does not change. The logic is exactly the same as when they were numbers. All right, and then we say, all right, well, m squared, that's the same thing as just 3m squared. That's the same thing as 4m and plus 1. And can we do anything with this? Are there any like terms or whatnot? No, that's it. Right? So I agree it doesn't look any better than what we had before, but I'm trying to make the point that the process is the same, right, as if we were substituting numbers in for our variables. All right, I want to do one more. All right, this time when x is 2y. All right, so we're going to put 2y in for x, so 3x squared, so I get the 2y in there, minus 4 times 2y plus 1. All right, now we can simplify this up. What's 2y squared? Well, from before, that's 4y squared. And then negative 4 times 2y would be 8y plus 1. And then what is that? 3 times 4, so it would be 12y squared. Whoops. 12y squared minus 8y plus 1. And there's nothing else we can do with that, but we've got a different expression. Right? So the process is the same whether you're evaluating a polynomial with a number, with a letter, or with an expression. The process is the same. Replace your variable in your polynomial with whatever you need to replace it with, and then simplify it up. All right, that's it. Study well, and please let me know if you have any questions.